Look at question number 9 from the 2013 Revised Higher Physics paper. It says a train is approaching a bridge travelling at a constant speed of 16 meters per second. The horn on the train emits a sound of 277 hertz, which is heard by a person standing on the bridge. We're told the speed of sound is 340 meters per second. And the question is, what is the frequency of the sound heard by the person on the bridge? Now the key idea here to remember is that these sound waves being emitted by the horn on the train are being compressed as the train travels toward the bridge because it's moving in that direction. And so the frequency observed by the person standing here is actually higher because it's getting more waves per second than if the train and the person were stationary. So it's higher than 277. So we can immediately eliminate a few of these options, 265 and 277, because that would be equal to the frequency emitted by the horn. So it's going to be C, D, or E. I'm going to predict C just because it's a higher number, but it's not too high. Remember, the speed of the train is not overly fast. So let's write down the formula from the datasheet. The frequency observed is equal to the frequency of the source, which in this case is the train, multiplied by the speed of sound divided by the speed of sound minus or plus the speed of the source. So the question is, do we use minus or plus in this instance? The way I tend to remember this is if the train is moving away, we use add. So add equals away. The two letters A and A match up, so add is away. In this case, it's not moving away, it's moving toward the observer, so we must use the negative symbol. So we plug that in, all the numbers into the equation. The observed frequency is the source frequency of 277 times the speed of sound, 340, divided by the speed of sound again, 340. In this case, add is away, so take away is toward, and that is 16. So let's plug the numbers into the formula and see what we get. Put them into the calculator and see what we get. So the calculator gives us 290.7 hertz, and everything is given to 3 sig fig here. That's 3 sig fig, and so to 3 sig fig, that's 291 hertz, which is what I predicted. So the answer is indeed C.